Hello friends, today we shall discuss the inverse Laplace transform by the two different methods, namely method of partial fractions number one and the convolution theorem. So let us see this. F of s is equal to 1 upon s plus 1 into s square plus 1 obtain L inverse of 1 upon s plus 1 into s square plus 1. This is the function of s, 1 upon s plus 1 times s square plus 1. 1 upon s plus 1 into s square plus 1. Its inverse Laplace transform we shall now finding it out by two different ways, namely partial fractions and convolution theorem. First method of partial fractions. So this f of s, we shall resolve this into the partial fractions. What is f of s? F of s is 1 upon s plus 1 into s square plus 1. In the denominator, we see that there are two factors. One factor is s plus 1. The second factor is s square plus 1. S plus 1 is a linear factor, whereas s square plus 1 is the quadratic of degree 2 factor. So, as we are resolving into two proper fractions, this s plus 1 factor, it must be resolved by constant upon s plus 1. The degree of numerator must be less than that of the denominator. Then that fraction is said to be proper. So this linear factor is associated with constant of degree 0. Now this quadratic factor, this is of degree 2. So this is resolved as bs plus c. This is of degree 1 upon s square plus 1. So we shall now find out the values of constants a, b and c. So how do we determine the linear factor? Linear factor a is equal to, see here, that is equal to limit s tends to minus 1, the denominator, of 1 upon s square plus 1. So it is 1 by 2. So value of a, capital A is half. Now B and C. Now let us simplify this. 1 upon 1 is equal to, cross multiply this, A into s square plus 1 plus bs plus c into s plus 1. Numerator of left hand is equal to numerator of the right hand side. This equation 1. That is further equal to. Now how to find 1 is equal to? I am substituting for capital A is 1 by 2 s square plus 1 plus bs plus c into s plus 1. bs plus c into s plus 1. bs plus c into s plus 1. a into s square plus 1, bs plus c into s plus 1. Now, how do we determine this b and c? Put any value of s. S is equal to say 0. Put in this equation. So 1 is equal to, I am putting in this equation s equal to 0. 1 by 2 times 0 plus 1 is 1 plus this is 0 plus c into 0 plus 1. This gives me c is equal to 1 by 2. So both capital A is 1 by 2 as well as c is also 1 by 2. Now, earlier I had put s equal to 0. Now I am putting s equal to 1. So, in the same equation, so 1 is equal to 1 by 2 times 1 plus 1, 2 plus s is 1, b plus c, b capital B plus c is 1 by 2 into 1 plus 1. Because c is 1 by 2 and s is 1. 1 plus 1 is 2. So 1 is equal to 1 plus 2b plus 1. So 2b is equal to minus 1 and b is equal to minus 1 by 2. So we have found the values of a, b and c. Capital A is 1 by 2, b is minus 1 by 2 and c is again plus 1 by 2. Therefore, this f of s becomes a upon s plus 1, a is 1 by 2 upon s plus 1 plus bs plus c, b is minus 1 by 2 into s plus c, c is again 1 by 2 upon s square plus 1, which is further equal to 1 by 2 times 1 upon s plus 1 minus 1 by 2 times s upon s square plus 1 plus 1 by 2 times 1 upon s square plus 1. And now, after resolving this into partial fractions, taking the inverse, Laplace transform. I am writing down the inverse here, 1 by 2 times e to the power minus t, 1 upon s plus 1, e to the power minus t minus 1 by 2 times cos of t plus 1 by 2 times sine of t. That is the f of t, whose Laplace transform is 1 upon s plus 1 into s square plus 1. So, that is the method of partial fractions. Now, we shall solve the same example by the convolution theorem. So what is convolution theorem? If capital F of S is equal to, say, F1 of S into F2 of S, such that L inverse of F1 of S is F1 of T, and that was inverse of F2 of S, is F2 of T, then by CT means the convolution theorem, inverse Laplace transform of capital F of S or inverse Laplace transform of F1 of S into F2 of S is equal to integral 0 to t F1 of u into F2 of t minus u du, or it is also equal to integral 0 to t F1 of t minus u into F2 of u into d. The inverse of two splitted functions F1 of S and F2 of S, whose inverses we know, then by this definite integral 0 to t F1 of u into F2 of t minus u, or F1 of t minus u into F2 of u, this integral gives us the inverse of their products. Now we shall see this. F of S 1 upon S plus 1 into S square plus 1. This is product of two functions. 1 upon S plus 1 into 1 upon S square plus 1. I have expressed the given function F of S into two different products such that inverse of each term I know. Inverse of 1 upon S plus 1 I know. Moreover, that of inverse of 1 upon S square plus 1, that is also known to me. Now, I will be considering this as F1 of S, and this is F2 of S. F1 of S is 1 upon S plus 1, therefore F1 of T is e to the power minus t, and F2 of t, their inverse, is sin t. Now, out of these two functions, one is exponential e to the power minus t, and another is the trigonometric function sin of t. One of the functions is expressed as function of purely u, and another is purely t minus u. In one function t is replaced by u, in another function t is replaced by t minus u. So out of this pair of functions, two functions, choose the simpler functions, and that simpler function is t is replaced by t minus u. Out of these two functions, this e to the power minus t is simpler function. So I shall replace this f1 of t as f1 of t minus u. So e raised to power minus times t minus 1. And this f2 of u, it is sine of u. Therefore, L inverse of f of s, L inverse of 1 upon s plus 1 into 1 upon s square plus 1 is equal to integral 0 to t f1 of t minus u into f2 of u. So that is equal to, this is by convolution theorem. Therefore, L inverse of f of s is equal to, I will substitute this value, integral 0 to t f1 of t minus u is e raised to power minus t into e raised to power plus u, and f2 of u is sine u. This is to be integrated strictly with respect to u. So e raised to power minus t is, of course, a constant quantity. E raised to power minus t times integral 0 to t e raised to power u into sine u d. So that is further equal to e raised to power minus t times e raised to power ax into sine bx dx. I am using that formula. E raised to power ax into sine bx dx. Both a and b, they are 1. The formula is e raised to power ax upon a square plus b square. So e raised to power u upon 1 square plus 1 square, it is 2 into a sine bx means 1 sine u minus b cos bx means minus cos of u. The limits are 0 to t. E raised to power minus t times. Now put the upper limit, u equal to t, e raised to power t by 2 into sine of t minus cos of t minus, now lower limit, 1 by 2 times e raised to power 0 is 1 times sine 0 is 0, cos 0 is 1. So that is equal to e raised to power minus t times e raised to power t upon 2 into sine t minus cos t minus minus plus 1 by 2. So that is further equal to, open this bracket, e raised to power t minus t goes, it is 1 by 2 times sine t minus cos t plus e raised to power minus t by, so 1 by 2 seems to be constant, sine of t minus cos of t plus e to the power minus t. Same answer is here, e raised to power half of e raised to power minus t minus half of cos t plus half of sine of t. That is how our answer is tallying by both the methods. I am receiving the same answer. So, one more problem we shall solve. Obtain L inverse of s upon s square plus 1 to s square plus 4. So, L inverse f of s is s upon s square plus 1 into s square plus 4. That is equal to s upon or 1 upon s plus 1 into s upon s square plus 4. So f1 of s is 1 upon s plus 1 and f2 of s is s upon s square plus 4. There. f1 of t is s square plus 1. Sine of t and f2 of t is cos of t. Both are trigonometric functions. Therefore, f1 of u is sine of u and f2 of t minus u is cos of t minus u. Sorry, f2 of t is cos of 2t. 2 times t minus u. T is replaced by t minus u. Therefore, L inverse of s upon s square plus 1 s square plus 4 by convolution theorem is integral 0 to t f1 of u into f2 of t minus u du. That is further equal to. Now substituting by convolution theorem. Integral 0 to t f1 of u is sine u and this is cos of 2t minus 2u du. Sine A cos B, it is equal to 1 by 2 times integral 0 to t sine of A plus B u plus 2t minus u plus A plus, let me add this, u plus 2p minus 2u plus sine of A minus B, u minus 2p plus 2u. B. Sine A cos B is equal to sine of A plus B, 1 by 2 times of course, plus sine of A minus B. I use just that simple formula. So 1 by 2 times integral 0 to t, this is sine of 2t minus, sine of 2t minus u plus sine of 3u minus 2t. This is further equal to 1 by 2 times. Now I will integrate this. Sine of 2t minus u with respect to u. That is equal to minus cos of 2t minus cos of 2t minus u divided by minus 1 minus cos of 3u minus 2t upon 3. Limits are 0 to t. So minus minus becomes plus. It is 1 by 2 times. Now put the limit of u equal to t. So it is cos of 2t minus t is cos of t minus 1 by 3 cos of 3t minus 2t. Is t. This is the upper limit minus lower limit. Put now u equal to 0. This is plus. Now u equal to 0. Cos of 2t minus 1 by 3 times cos of 0 minus 2t. Cos of minus theta is same as cos of theta. So 1 by 2 times cos of t minus 1 by 3. It is 2 by 3 cos t minus 2 by 3 cos of 2t. Let us open the bracket. 2 goes, it is 1 by 3 times cos of t minus cos of 2t. So this is the function f of t whose Laplace transform is this, and inverse of this is this. 1/3 of cos of t minus cos of 2t. If you find the Laplace transform of this, you will get this function. So thank you very much. Thank you.